Hi everybody, I'm Greg Fishel. Welcome to bonus weather video number 3 for this week. This is going to be fairly short, and we've talked about a lot of this before. Just going to present it in a slightly different way with maybe a few extra numbers, but it's not going to be long or complicated, so no need to fret. So let's move into things here. And here you're looking at a table, and I've titled this Astronomy is Rarely Symmetrical. But I'm going to look at the period of time from December 17th until Christmas Day, the 25th. Now notice on the 17th, the sun rises at 7:19:20 and sets at 5:03:47, gives us 9 hours, 44 minutes, and 27 seconds of daylight, and the solar declination angle is 23.388 degrees south of the equator. Now, if we move to the next day, the 18th, the sunrise gets 35 seconds later, but the sunset only gets 25 seconds later. So the days are still getting shorter. We lose 10 seconds of light. Next day, 34 seconds later, 26 seconds later. So the changes are getting closer. We're still losing light at 8 seconds on that particular 24-hour period. Then on the 20th, the sunrise 32 seconds later, the sunset 28. So now we're just losing 4 seconds. And tomorrow, on the first day of winter, the sunrise is 31 seconds later, the sunset is 30 seconds later, so we lose a whole whopping 1 second, and the solar declination angle is as far south as it's going to get at minus 23.441. Then on the 22nd, the sunset is getting later than the sunrise by an amount of 4 seconds, so we gain 4 seconds of daylight, and by Christmas Day, the change or the difference between the two is 12 seconds, and so the sunset is now getting later at a quicker rate than the sunrise, and so as a result, we gain from the 24th to the 25th 12 seconds of light, and of course that rate increases as we head farther into the winter and eventually the spring and into the summer. Now, why is the shortest day not the coldest day? Well, I'm going to compare December 21st and January 17th, and that black area there with the little white dots is my poor man's representation of outer space. So, we have the sun on December 21st, but there is less radiation coming in from the sun than there is leaving the Earth and escaping to space, okay? So, even though the days start to get longer after December 21st, there is still more radiation leaving the Earth than there is coming in, and so climatologically it continues to get colder until about the 17th of January. And at that point, the amount of radiation coming in from the sun starts to be just slightly greater than that leaving the Earth, and so the average temperatures begin to increase in the middle of January, and that rate, of course, accelerates as we head into February and March. Raleigh-Durham receives 2.67 times as much solar radiation on the first day of summer as it does on the first day of winter. So that, of course, not only relates to the length of the day, but also the fact that the sun's rays are becoming more and more direct, and the sun is almost 80 degrees above the horizon on the first day of summer, whereas on the first day of winter, tomorrow, it's only about 30 degrees above the horizon. So it's like somebody shining a flashlight in your face almost directly, as opposed to shining it from the side, and it's not nearly as noticeable when it's coming in from the side. And just to take a look at the normal temperatures on the first day of winter and the first day of summer, and compare that with when the average temperatures bottom out and peak. On December 21st of 2024, tomorrow, our normal high is 53.5, normal low 33.6. That gives us an average of 43.6. But we don't bottom out in the normals department until January 14th. That is the climatological bottom, if you will, of the average temperatures. And then on the first day of summer, June 20th of 2025, the normal high is 88.6, normal low 67.2, normal average 77.9, but we don't reach the peak of the normals, if you will, until July 16th, which is, 26 days later, okay? And at that point, the normal high is 91, the normal low is 70.5, and the normal average is 80.8. So from December 21st to January 14th, that is 24 days, and the other difference is 26 days. So it's more than 3 weeks, between 3 and 4 weeks of a lag there, where there is a, even after the longest day of the year, it continues to get climatologically warmer for a 26-day period. And in terms of December 21st and January 14th, the averages continue to get lower for a 24-day period until things start to turn around. Okay, that is it for now. That's bonus weather video number 3 for this week. I hope you have a wonderful Friday evening and an even better weekend. Make sure you stay warm, finish up that Christmas shopping, and we will talk to you again on Monday. Take care, everybody.